Hello there, and welcome to the second part of my binomial distributions. This is going to start involving inequalities. And my apologies for the length of the last video, but unfortunately, trying to get around the ideas that you can use within a binomial, especially when it involves the mean and the standard deviation, creating a probability distribution, there's a lot of ground to cover in that. And we're going to just quickly hit a quick refresher about the items that you need to pull away from that particular video. So for starters, you need to know that there's a certain amount of trials, there's a fixed rate of success, and there's a certain amount of successes that you can have. Now, if you are asked to find the probability of any certain amount of successes, well, in that case, the n and the p and the x are all going to be given to you, and you should have the following formula. N choose x times p raised to the x power times q raised to the n minus x. Now keep in mind that q is still equal to 1 minus p. So these are all the items that you need to pull off the last video. And if you keep following along and you really want to know why we want to worry about these particular probability problems, well, for starters, you're going to have a variation on n and you're going to have a variation on p. Perfectly fine. Anybody can get around that. But in the last video, we started talking about all the likely chances. So x could be 1 or 0 or 2 or 3 or 4. And that gets a little monotonous after a while, especially when you got to do like 80 or 90 items. Hello, that's what we have technology for, right? Still got to know the fundamentals. So what if we wanted to simplify this particular problem to, let's say, just 2 examples? We want just 0 or 1 successes. Well, if that's the case, then we just set up our formulas accordingly. So the probability of 0 successes is n choose 0 times the likelihood of getting 0 successes and the likelihood of getting that amount of failures. Okay? So let's do probability of 1 success, which is taking n choose 1, so the combination of 1 success, times the probability of 1 success and that amount of failures. Once again, keep in mind, n choose x, p raised to the x power, and this q gets its n minus x, and if x is 0, then you just end up with n. Okay, and that's how the other equality gets its power. Everybody still with me? I hope so. So, in the end, you can add these 2 events together so you can look for the likelihood of getting 0 events or 1 event. And that's not a problem because you can answer in decimal format. But there's a big but to this. You cannot go through the second part, which most students want to do, and find the likelihood of 0 and 1 successes, because that should be 0. Wait a minute, why does this have to be the case? Let's use a fair example. If we're talking about a 2-sided coin, where one side is heads and the other side is tails, and I want to flip 5 coins, of course, probability of flipping a head is 0.5. And let's say I want to flip 1 head out of the 5 coins. So, can I flip 0 heads if I want to flip 1 head? No, you can't, because you're assuming that you flipped 1 head. Well, if I turn the tails around and I say I want to flip 0 heads, can I flip 1 head and have these both happen at the same time? No, because you're already making the assumption that you flip 0 heads. So, in the end, can you really have 0 and 1 likelihoods of success? Sorry, no way in heck you can get anything around this except for 0. And that's just because the logic behind probability, this and means at the same time. It does not mean to multiply. Some people will get that mixed up with earlier statements in probability. Don't. In binomial distributions, odds are you're going to be using some form of addition. Still with me? Good. So if we really wanted to go off, we could try and find the likelihood of multiple events that could have occurred. So 0 or 1 or 2 or 3 or 4 likelihoods of success. Okay, no biggie, how do we do that? So we'd find the likelihood of 0 successes or 1 success or 2 successes or 3, yada yada yada. And we'd have to do each one of these items individually. Well, what's the difference between that and what we did in the last video? Well, the difference is that you may not have to do it n amount of times. But this is still a lot of monotonous work. You have to find 0 and then 1 and then 2 and then 3 and add them all up together. So there's technology to do that, right? Yes, there is. And if you want to use that technology and respect that technology, sorry, gotta wait until the next episode and we'll start talking a little bit more about what the technology does to help you on your track. So in this video, we described you can take the likelihood of multiple sets of what could have been. So 0 or 1 or 2 in terms of addition, but you cannot do 1 and 2. You can't have any of these two things happening at the same time. It just does not work. Well, thank you all for watching my video. See you next time.